and I must have touched some kind of a trip line because
Oh,
hundreds of them jumped on me and started biting me. I just never thought I would ever experience anything like that.
hello, welcome. This is DJ Butler, senior editor of Arc Press. Welcome to the Gopher Wood Lounge. Come on in out of the rain. Take a moment here. We got an exciting guest to talk about fun stuff with us today. But before we get to that, just briefly, let me invite you to like the video, subscribe to the channel, hit the notification bell, all of those things. Our guest today is a guy with an interesting biography and a wide range of feats to his name. And I want to talk about one particular line of research today. I want to welcome Dr. Robert Furey to the program. Rob, thanks very much for
Hi.
joining us.
Yeah, my pleasure. Thanks for asking me.
So, I have to say, the phrase social spiders is not an obvious one. Uh, what are they, and how did you get interested in social spiders?
Well, socials. So you've got about 37,000 species of spiders in the world, and most of them are pretty ferocious and cannibalistic. But there's a small number, about, let's say, 15 to 20 species that we can find living together throughout their life, sort of like a bee or an ant or a wasp. They live in these persistent colonies of family groups. Um, Sometimes in very, very large groups. Now, some of the ones that we have in North America are smaller than ones that you find in tropical areas, and that's probably because of the seasons. So here, they get knocked back, but in Africa, for example, or in the Amazon, for example, that they never do, and the nests get larger and larger and larger until you get groups of up to 10,000 individuals all in the same nest. They don't leave the nest. They stay there the whole time. They have a little bit of differentiation in tasks, mostly depending on just their physical size. They don't really have a caste system. Um, there's a big sexual ratio skewed to females. Sometimes, especially in South America, you can see some of these colonies with 10,000 spiders in it, and 7% of them are males. So most of them are females. Females are larger, so they can hunt better, build better, they're tougher. The males don't really do much of anything except mate with their many, many generations of sisters and inbred sisters over and over and over again.
Wow. So that's just, is that the natural birth ratio? There's not some effect that's keeping down the number of males, external effect like a predator or something?
Well, it's probably not a predator. It could be, what it could be is something inside the cocoon. That's and actually I just thought of this because there's a thing in spiders called trophic individuals.
Okay.
And trophic individuals are individuals that are there to be eaten. And when you have spiders inside the cocoon, you see the little cocoons, the ones that you see in your garage probably have 300 spiders in there. And they hatch and they go through several instars before they come out. And so they got to have something to eat. So they eat each other. And this sexual skewed ratio for social spiders might be that males tend to be the trophic individuals more than the females.
Interesting.
Maybe, I don't know.
Right. But once they emerge, they're not generally cannibalistic. They're social.
Right. So the years that I spent just watching these guys, I saw one event, cannibalistic event once.
Yeah.
So it happens.
Yeah.
Even people do that, I suppose, every once in a while.
Once in a
But
while, you observe them for years, you'll encounter one.
yeah.
So where you go? Are these social spiders? I mean, are they equally distributed around the world? Are they all tropical? Or are they in one region? Where do you go to study them?
Well, for many, many, many years, people used to call it the field station distribution because you would find them around these tropical field stations, which was sort of tongue in cheek, um, false correlation because you see them there because that's where you go. But we found them. I did a lot of work in Gabon. I did a lot of in Equatorial West Africa, and then I
Mm.
worked on them again in Central America, different species, Central America and French Guiana. Did a lot of work in French Guiana, and then most recently Brazil. So these guys are all in the tropics. But when I did my graduate work at the University of Tennessee, Knoxville, I found them on the Tennessee River, and they were not supposed to be there. And I guess since I had, the search image in my head, I saw them and other people just hadn't seen them. And when I went over there, sure enough, there they were. So that was the first recorded case of them being in temperate areas. So if you would have asked me this, ask anybody this 20 years ago, they would have said these are tropical. But now it's no longer the case.
That's interesting. And so, are you in all of these research stations to study the same species?
No, so the one in Africa was Agelena consociata. It looks a little like a little grass spider, funnel web spider. We have these in North America.
Mm.
Um, they're in gardens and they're flat on the ground with a tube and they hide in the tube.
Okay.
I'm sure most people have seen them, even if they didn't pay any attention to them. But so
Yeah.
that was the one that was in Africa, and then the one in the Americas, it was Ankylostomus, a couple different species, but always Ankylostomus, and that one has sort of a cobweb. So the one in Africa had these sheets, and was more cobwebby here, and that one's these are Atheridiidae spiders, and those are Ageleniid spiders. For the taxonomists in the audience, that's what's those were the families. But
So,
I've seen other ones in India. I didn't work on them, but I saw them, and I saw some in Uganda too. But I didn't work on those either. I just saw them out there.
so that's interesting. So I think what I'm hearing you say in Tennessee and India and Uganda, you recognized a social spider, not necessarily a particular species. You weren't there to study the species. How do you recognize a social spider? I mean, is it a colony pattern? What
Yeah.
does it
So
look like?
well, sometimes you got to get up on top of them because the colonies, unless they're huge, the colonies can look like a common spider web. The characteristics might be a thicker central area because that's where they would all hide, and it has to be large enough for a group of them to hide. And then they have this flat. You can't so this flat area like this where they hunt on it. So a sheet where the insects fall. Most of them have this vertical scaffolding, so it sort of makes a maze so they can't get out. And I guess if I was to say that look for a social spider gestalt, that would be it. So it's sort of a ball, a flat thing, and these strands that go up and down.
Oh, interesting. And that's true across species.
For the most part, yeah. Yeah, it's the effective structure when they have to feed multiple spiders in the same place. Because all of these social spiders have close relatives that are cannibalistic. So they have to tampen down that drive to defend their territory so much that they'll eat each other.
Yeah, that's super interesting. So if you have, I mean, I didn't count, but 4 or 5 countries it sounded like in Africa and Brazil and elsewhere.
Mhm.
And you're studying different species. Does that mean you were studying or have been studying the phenomenon of sociality in spiders? Is that?
So we were doing two different things. We were looking for a caste system and
Mm,
a division of labor.
yeah,
So all the things that you hear about in ants and bees. You've got worker bees, you've got queen bees, you've got drones, you've got nurses, you've got foragers. You've got all these individuals that are specific to jobs. Even though in honeybees, it's sort of a temporal thing where it changes. They change their jobs as they get older. But we were looking for the same kind of thing in spiders. We just never found it. We had some indication of it in the spider in South America, but nothing real hardcore. The only real caste difference we see was males and females.
male, female, yeah. That's interesting. And that's true across the social spiders generally that you've
Yeah,
studied.
yeah.
So, is that true among cannibalistic spiders also, or is that something?
How do you mean?
Well, so um, if you had well, I guess actually, maybe I'm asking a dumb question. Let me ask the more basic questions. Do cannibalistic spiders then not live in a society where caste would make any sense?
Oh yeah, they're all solitary.
They're all solitary, right? Okay.
Yeah, yeah,
Therefore, there is no caste. There's just the spider.
right.
Um, very interesting. So,
And even in those, it's very dangerous for males to approach a female because they'll kill him too. So there's no exceptions made. If he comes up and he does something wrong, they'll just kill him and eat him.
yeah, yeah, rough to be a male spider.
Yeah, it's triggering.
Yeah. Uh, so you were looking for caste principally. The question was, do we have worker spiders and other kinds of specialists? And the answer is no. We have males and females.
Hmm.
Um, so I so one of the phrases that was, and I can't remember if it was Tony's email or I think it was an email from you to Tony, used the phrase emergent intelligence in talking about these spiders. Tell me
Yeah.
tell me what that means. What is emergent intelligence and generally, and what does it mean in terms of what she's found among the spiders?
So emergent intelligence or emergent behavior or emergent phenomena is when you have something, whatever that is. In this case, we're talking about problem solving in spiders. So it, every spider has very simple things that they do. And if they did this, if they were all by themselves doing those simple things, then nothing would come of it. But since they're all doing these simple things all at the same time, there develops a complexity, and that complexity then is something that solves these problems. I can tell you one of the people that I worked with had a robotics lab in Brussels, and the guy that I was working with in South America we're doing spiders, and we came up with this. We saw this emergence in the spiders, and he was doing emergent behavior in robots.
Interesting.
And so it's probably simpler to tell you what the robots do because their behavior was simpler. But
Yeah.
so he would take these little robots about the size of a shoebox that looked like a bulldozer. So it had a little push plate in the front. There
Mm.
was no computer in the robot. So you put them in, you turn them on, and they would just go in a straight line until they hit something that was heavy enough to push in that push plate. And then they would stop and they would back up, spin around, and go off in another direction, random. So if you had a room filled with blocks that were half as heavy that could trigger that push plate, it would go in the room and just push blocks around all day long. If it pushed one block, it would push it along until it hit a second block, then it would stop and do its thing.
Mm.
But when you put a whole bunch of robots in there with the same simple code, they started building piles of blocks that they could not build on their own. So the construction of these very simple rudimentary, block circles could
Sure.
only be done with the emergent behavior of these little robots. And the spiders do the same kind of thing. It's just a little bit more complicated. So the spiders walk along and they anchor a web, and then they walk again and they anchor a web, and they walk again and they anchor a web, and then they shoot some out in the air, right? And they just do this over and over and over again. And if they were to do that over and over and over again, they would just keep going and nothing would happen. But when they all get together, then they do this, they start the webbing of other spiders triggers other spiders, and you start getting these masses of webs. And the webs get massed, and then that's more attractive to the spiders, so they stay there. So so it's an emergent behavior of these spiders that build these very complicated webs in an architecture that would be impossible for a single individual to build, even on a smaller scale.
Yeah.
Does that make sense?
Absolutely. So, this is true of males and females both, by the way, or is this like a
Yeah, they both do that.
So that's interesting. So and it's just this basically this is the one phenomenon or the principal phenomenon you're looking at is basically this complex house building triggered by this one behavior. Um is what do you think the connection with the sociality is? I mean, is it you could imagine that um the attractiveness of the houses might basically I mean, I don't want to commit like a teleological fallacy here, right? But like if once the species started engaging in this individual behavior that individually did nothing, but collectively created a house, right? Um, that's it seems like that confers then a survival advantage potentially.
Yeah, that's
Spiders
right.
can stay together. Uh, you know, maybe that makes them safer. They maybe they hunt better collectively,
They
whatever.
do. Yeah. Yeah.
Hi, I'm DJ Butler, senior editor of Arc Press. How would you like to win $10,000? I want to talk to you briefly about the Arc Prize. The Arc Prize is a novel writing contest in 2025. The first thing you need to know is that the theme of the contest is America 2076. That is, of course, the 300th birthday of America, measuring from the signing of the Declaration of Independence. Our plan is to publish the winner on July 4th, 2026, which is to say on the 250th birthday. So your winning novel on the America's 250th birthday will be published talking about America at 300. Now, does that date 2076 mean that you have to write some kind of near-term science fiction novel? Absolutely not. You can interpret the theme America 2076 any way you want. Formally, we're launching the prize on March 8, 2025, which is, as we all know, all we writers and editors know, National Proofreading Day. And don't we appreciate those people? And the contest will run for 7 months, 7 full NaNoWriMos to end on National Taco Day, which, as we all know, is October 7th, 2025. Now, let me tease you a little bit more. I said up front you could win $10,000. Actually, the prize is a publishing contract with Arc Press with a $10,000 advance. So if the book does well, you might make more than $10,000 over time. There's more information and will be more information on our website. Information about the contest, information about how to write a proposal, the widget for submitting these materials on our website, which is www.arc.press. That's all from me. I look forward to hearing from you, and good luck.
So if they're together, imagine if you're a spider the size of a dime,
Yeah,
you can probably take down a fly.
yeah,
But if you are a spider the size of a dime and you have, 100 of your sisters, then you can take down a lizard.
yeah.
So it opens their ability to take larger prey. So they do get this payback. The problem, though, is that one of the problems that we had in eusociality is that they should be fighting each other. They should be killing each other. It should be individuals competing for each other, but they don't. And you should be reminded of ants and bees that have this. It's a genetic system called haplodiploidy, where the females are diploid. They have 2 sets of chromosomes, and the males only have 1 set of chromosomes. So whenever you have daughters, they get an entire set of chromosomes from the father, and every daughter gets the exact same set. And then they get half the chromosomes from the mother that they share. So sisters are 75% related to each other genetically.
Yeah.
So spiders can, because of what happens and all this inbreeding, you sort of mimic this haplodiploidy elevated genetic relatedness, and that's how we think that they're not killing each other, because they're so closely related. The problem then is that they're also accumulating bad mutations. So then they die.
Oh, that's
And so
interesting.
when you look at social spiders in evolutionary time, it's really interesting because we have so few of them, but they do really well, but they don't last very long. So if you think of evolution as an adaptive landscape with these peaks and valleys, we have peaks of social spiders, but once they get up there, they're stuck, and then they go extinct, but somebody
Yeah.
else takes their place. because for a spider, it's a really good place to be. You just can't stay there a long time because you inbreed yourself to death.
Because you get mutations. That is so fascinating.
Mhm.
Um, uh, so does that suggest then that a cannibalistic spider is more likely to stay sort of in the evolutionary record, we're more likely to see the same cannibalistic spider with relatively little change, whereas maybe I'm restating what you were saying in terms of peaks and troughs, whereas you'll see species of social spiders come and go because they'll come thrive for a while and then basically disappear.
That's a big question. I would guess that solitary spiders are more persistent, but
Yeah,
I don't really have the data to say that for sure.
yeah, yeah, that's interesting.
But but we do know that social spiders come and go regularly.
Yeah.
And it's a much smaller data set to track.
Because there's so few species of social spiders.
Hmm.
Yeah.
Yeah.
And I'm not sure I heard one way or the other. So the places you studied these other you found some in Tennessee, but the places you all deliberately went to study, all the places you went deliberately to study were tropical. Do these tend to be tropical species?
Yeah. Yeah, they do.
Is there something about the tropical climate that we think causes a spider to?
Lots and lots and lots of insects.
Oh, that's interesting.
So you can get, once you have this enough food so that they can keep themselves fed and don't have to kill each other, then they hang around. In fact, there is a spider around here. So these things are obligate social spiders, but you also have these others that can sort of switch. We have one around this area in North America called a long-jawed spider. And when you find a long-jawed spider in your garage, it's solitary. But when you find a long-jawed spider living near water, they all clump up. And they can do that because the water attracts insects too. So they would rather eat insects than each other. So then you get this sort of a quasi makeshift social spider structure that's only going to be persistent as long as there's a lot of food. And as soon as the insects go away, they get aggressive to each other and they disperse.
Oh, that's super fascinating. So food abundance, if there's not food abundance, you're only going to have solitary spiders, and the spider can go along anchor, throw a line of silk, doesn't matter. It's the
Mhm.
food abundance attracts lots of spiders, and then the same spider may engaging the same behavior with its other spiders, then creates the house, the more complex nest. Um, okay, very interesting. Uh,
Right.
so do you find that these spider species are they I'm going to ask a question that probably is really stupid. Are they variants or are they closely related to so the long john's an example of a spider that you see it both solitary and where the food is abundant you can
Mhm.
see it as a social spider. Um, um, where is there a broader is that a broader phenomenon? Like if you go down and you're in Brazil and you see a spider, a social nest, are you likely in, I don't know, the highlands or something over in the Andes to find a very similar spider that is living solitary? Or are they?
Sure. Yeah. Yeah. The one that we have, the one that's in Brazil, again, it's Anolosimus eximius, but we have solitary Anolosimus in North America. And they're the same, very close morphology to the social spider one. I think the social spider one's a little bit smaller though.
Yeah.
But yeah, we have those. So yeah, we have a genus that can contain solitary and social spiders, and presumably, if for something happened to the population of Anolosimus eximius, another Anolosimus could step right up,
Yeah.
take its
Yeah.
place.
And presumably would, right? I mean, if there's sort of a gap in like an empty niche in the ecosystem, just the
Yeah,
random movement of the bulldozers, some of the bulldozers are going to get over
yeah,
there.
yeah.
Uh,
That's right.
yeah. That's super interesting. So, are there other spiders where or sorry, spiders? Are there non-spider species? Like where else do we see um this kind of emergent intelligence, right? Or emergent behavior?
You can see emergent behaviors in slime molds. You don't even need a nervous system.
Wow.
You can put a slime mold in a petri dish with little bits of food, and the slime mold spreads out and then figures out the most efficient way to go from each one. And you see this pattern emerges in that petri dish. And I think they've done experiments with this to design subway systems to 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 shorten the route between stops. And architects that go to college for years and then grad school come up with the same solutions that the slime molds come up with in a petri dish. So you don't need a brain.
That's super interesting. So, do you take any kind of lessons for this from this for human biology? Like, is there an idea that we might be on some levels engaging in sort of similar are we a more complex version of the same kind of phenomena on some level?
I think without question we have emergent behaviors. I mean, have you ever been to a concert and just the crowd goes crazy and you go crazy too, and you're not thinking about it, you just go because you do everybody does these little things that we trigger each other into this common stuff. And yeah, I think it's very likely that we have lots of them that we don't even recognize. The way crowds move, the way cars travel, the way, traffic jams and people walking through shopping malls. I mean, these are all things where we're all taking triggers from each other and behaving in ways that at some evolutionary level was designed to do something good, and we still have these things.
Yeah.
I mean, you can see the way like birds space themselves out. Have you seen those murmurations, the giant murmurations of the birds, and they do this shape in the sky and they move around? Starlings do it a lot. Yeah, I think human crowds do that too.
Yeah.
I mean, good and bad. I mean, you can get swept up into with some kind of a charismatic leader that you wouldn't really like by yourself, but you're with a crowd that screams. I mean, there's a book and where Conrad Lorenz, I don't know if you know who he is, but he
Mm,
started the ethology. He was one of the founders of ethology, which is a
mm,
branch of animal behavior. And
mm.
he talked about going to some of the rallies in Germany, and the people around him were screaming, and he would come home and just be mad at himself. But when he'd go to the rallies, he'd scream right
Yeah.
with everybody else. And
Yeah. That's super interesting.
yeah,
This is sort of probably in a similar vein, but I was thinking something like the play 12 Angry Men, right? And sort of there's something human about this, um, recognizing, hey, I can be caught up in these sort of forces greater than myself,
yeah,
and making a deliberate choice to stand against, right? Whether it is something, like Dietrich Bonhoeffer in Nazi Germany, or fighting for the reasonable doubt in the play when everybody else, um, there's this kind of collective movement, and I think this is very natural to okay, I'm going to go along, I'm going to fit in, I'm going to mimic the others.
yeah. People want to be liked.
Yeah, people want to be liked. Um, so okay, so this is interesting. So you and I talked a little bit before. This is the first chance I've had to interview, and I appreciate it, Rob. It's interesting stuff. Um, but I have reason to think you might be a science fiction reader. Is that right? At least some.
Yeah, yes, sir. Yeah.
So so uh I'd be interested in your take, if you've got any examples of Well, I mean, there's like a couple of things that are interesting. Like one, if you have any thoughts on science fiction movies or books or other kinds of media that you think show emergent behavior in an interesting or a kind of compelling way. And I didn't prep you for this question at all, so you might say, "Look,
No,
pass."
no, you
That'd
didn't.
be
It's
fair.
yeah. I think well, probably the movie version of Starship Troopers.
Oh, interesting.
Yeah. And maybe the sand trout in Dune.
Oh, yeah.
Yeah. So yeah, something like that. And Star Trek, you've got your Borg cubes. I
Yeah.
mean, that's exactly what they are. They forfeit everything to they don't even care if they're liked anymore. They're collective and they go back to emergence. So yeah, there's lots of examples in science fiction for that.
Yeah. I love
There
that
was
you
another one, Werner Vinge wrote something with some kind of they were dog-like. God, I can't remember what that book was. I shouldn't have brought it up. Never mind, can't
uh-huh.
remember.
So it's all right. It's all right. I like that you went to Dune. I think Herbert was kind of cutting edge for sort of thinking deep thoughts about the ecology. Um,
Hmm.
and so the sand trap. So remind me. So these are not the sandworms, although don't we learn that they're basically the nematode version of sandworms?
Right,
But the reason a reason why the desert planet Arrakis is so dry is that the sandworms or the
sand trout.
sand trout basically go wall off the water for their own use.
Yeah,
Um,
yeah,
what a great example. That's such a great example. So each individual sand trout, all it's doing is finding water and putting itself in contact with the water, right? But the collective result is the desertification of the planet,
yeah.
because they go surround and absorb every water source.
Hmm. Yeah. And
Fantastic.
then I guess when Leto touched them, they all crawled up his arms and covered him,
Right.
worked together as a like a still suit. Yeah, so there was that too. So and in that case, it was sort of tricking them into doing something else by abusing their emergent behaviors.
Yeah. Because this is basically Leto's process for turning himself into kind of a human sandworm hybrid,
Yeah, yeah.
right? God Emperor of Dune. Fantastic. What a great classic example. Um, so I think I have one more question. Although I want to make sure we haven't missed anything we ought to talk about. When you went to all these places to study spiders, so I assume that must mean like you could just have spiders shipped to you in a box and you could study them in a terrarium or something. I assume you must have wanted to study them in their habitat.
Well, yeah, I mean, there's things. I mean, I did a lot of that in the lab. So I don't want to say it didn't, but there's things you can't do in the lab.
Yeah.
For example, there's things that you wouldn't even think about. Like, so spiders, remember we said that spiders are doing this so that they have access to a lot of food. So as they're growing, their nest is getting larger and larger and larger. There are parts of the nest that are no longer accessible to insect prey, so the spiders don't want to be there. So they're
Oh,
leaving. Yeah, so they leave these abandoned parts behind. And what I found was that these abandoned parts are then they fill up with squatters. So you've got ant colonies that move in and little isopods that move in and there's a bat that lives in the ones a caravula bat that lives in them in Africa and vipers and all kinds of shit move in. Oh, sorry. A lot all kinds of stuff moves in there. That you just wouldn't know
yeah.
if you were only looking at them in the lab. So they end up with a lot of organisms that sort of depend on them. As far as I know, the Caravula bats don't even live anywhere else, or at least I haven't seen that they've been anywhere else, but found inside these spider webs.
That
Hu-
boy,
And
that
the-
is that's fascinating. So
and
all
and
of
you've got a whole other group of things that are in there that are called kleptoparasites. And these kleptoparasites are other spiders that mimic the social spiders that eat the social spiders or steal their prey. So these kind of things you just can't see without being in natural conditions.
Yeah. So this is fascinating, right? Uh so all this is driven by basically two things. The spider goes towards food, and as the spider moves, it anchors a web several times and then casts out a line of silk. And the
Mhm.
result of 1,000 spiders doing that builds a city, a nest, right? Which gives the spiders advantages, but it's also dooming them to eventual death by mutation. And
Yeah,
also as it gets bigger, I mean, it's like you're describing Detroit or something. It leaves behind
yeah.
desolated zones, um, and there are species. I mean, so like including potentially a bat that basically is sort of symbiotic to some extent with the spider because they just
Yeah,
what's hey, there's this spider going around building perfect nests for me. Uh, and for its part, presumably the spiders, the bat's not engaging in complex analysis. It's just looking for its ideal home. Well, it turns out the home that suits it is the interior, the abandoned interior of the spider metropolis.
right. And they don't really interact. So there's no the only benefit is that the ants get it.
Yeah,
Excuse me, the bats get an advantage for being in there. And nobody really pays a cost
yeah, that's super
because
interesting.
that the webs are tough. I mean, they persist.
Yeah. So the bat has shelter. The bat's protected from
Bats got
and
shelter,
and,
yep.
and hidden, maybe.
Hmm.
Um, that's fascinating. So should we imagine you kind of out there with a magnifying glass and I'm going to check in on the colony and lift a strand and look, what would that look like if we were
So I would try not to actually touch
Mm,
anything. I mean, I made, I mean, what I would do is go out and first off, I barrel through these things and I collect as many spiders as I can, like 50 or 100 spiders. Then I had tester paint and I would put little dots on them so that I
mm,
could identify them, and then I put them back.
yeah,
And then I would never touch it again. So I would be able to go in there and say, all right, spider 12 was interacting with spider 31. This is what they did. Yeah, and that's why I did it. Now the only time that I made the mistake of touching it was once in I was in French Guiana, and
mm,
I had gone inside one of the webs, just like I'd done in Africa a million times. I went inside one of the webs and I must have touched some kind of a trip line because
oh,
hundreds of them jumped on me and started biting me. I just never thought I would ever experience anything like that, but they were all
yeah.
over me, biting me. It was crazy.
Okay, so but these are your research subjects. So what do you do? Are you trying to shake them off without smashing
Yeah,
them?
I'm trying to get them off me and get out without hurting them too much.
Destroying the colony you're studying?
Yeah, it's like, yeah, yeah, it was a
Wow.
bad mistake. It was a bad mistake.
Uh, hopefully not too venomous. I mean, you survived. You're here, so
Yeah, I mean, it was everything turned warm. My skin turned warm. Didn't change color, didn't get dots or anything or blisters, but everything got kind of warm and then it went away.
wow. Um, well, Rob, thanks for sharing this with us. I think this is super cool. Uh, is there anything that you think we ought to talk about on the subject that we haven't? Any particularly interesting phenomena or uh, especially dramatic stories? What else should we tell people who are listening?
About social spiders?
Yeah, well, or anything else, but yeah, social spiders.
Yeah, I think well the best story was all the spiders jumping on me. I don't know.
It's a good one.
Yeah, yeah, that was the best one. I mean, really, I do think if you ever get a chance to see them, they're spectacular. I mean, the one where I told you that I was inside in Africa was bigger than a two-car garage. I I mean, they're
Wow.
just enormous, enormous. And it was about maybe a foot and a half, 2 feet from the forest floor. So you have to get down on your belly and crawl in, and then inside it gets hollow. So you get in and you can come up, and then there's all these holes, these gaps where you can see the bats and the vipers and the ants and all this stuff, and they're just it's like looking at the side of an apartment building, and they're all in their little nooks.
Okay, so I have been envisioning this totally wrong because when you were saying a flat space, I was sort of imagining this was the scale you were talking about, that these nests would
Oh
exist
no.
to be 6 inches wide or something.
I
You're
mean,
talking
some of
about a
them, some of
building.
them are, some of them
Yeah.
are like that, but those aren't the ones you remember. I mean, I'm talking like as big as a small house.
Yeah, holy cow. And but the spiders, is this a spider that's the size of a dime, like you were saying
Yeah,
earlier?
yeah, and that's leg spread. So the bodies are still smaller than that.
The bodies are smaller than that. So is that like 10,000 spiders? How many
Yeah.
spiders?
Oh yeah. At least, at
Oh man,
least.
the arachnophobes listening are getting a serious case of the creepy crawlies right now.
Yeah,
Uh,
I could imagine there would be some people that don't like that. Yeah.
yeah. So, okay, another mental adjustment here I'm making is you're talking about snakes that climb trees. When you say vipers, you're talking these are right. Because this is all hanging from like branches or overhead canopy of
Yeah, yeah. So what imagine here, so here's what it looked like. So you have this big thing, as big as the garage, and it's sort of hovering there, and then there's all these cables, thick web cables that are going up into the canopy, and it's suspended from that, and maybe a couple of branches that are
yeah,
holding it. So it's sort of floating in the air.
yeah.
Um, yeah, so stuff can fly in there, stuff can crawl in there. Yeah.
Wow. Okay. So sorry, I'm mentally adjusting my image. So and it's things touching the flat space under the canopy that causes the spiders to drop down on them. It's not necessarily things that run into the web.
No, no, no. Okay, so the way they catch stuff in general, so they have these vertical things that are holding it up. So you have flying insects that are coming along like this. They don't really see the vertical web. They hit the vertical
Oh,
web.
got it. Okay.
These strands, it's like just ropes, and they
Just
hit it.
individual strands.
And then they fall. And then when they fall, they're on a sheet. And this is the hunting sheet. All the spiders then come out and get them as they're on the sheet and just make a big ball of spiders and kill them.
Yeah, yeah.
So that's how they
Uh,
hunt. So the ones that were jumping on me in South America, that was not hunting behavior.
okay.
That was something else.
That's like a defend the
That was some kind of
behavior.
defense. Yeah. Yeah.
Okay. Okay. Super interesting. So the sheet in a nest that size, the sheet you're talking about, like these are leaves on the forest floor, or what's the sheet when you say look, the insect comes along, it hits the individual strand and then it falls. What's it falling onto when
Well, you got cables of webs going straight up into
yeah.
the air and to anchor stuff.
Yeah.
But then the flat part is all these spiders going in all these different directions. So they have woven a pretty solid sheet of webbing.
Oh, of webbing. Okay, got
Yeah,
it.
it's all webbing. So then the insects fall on the webbing and they try and get away before the spiders get to them.
Wow. Okay. So okay. So yep, I'm glad you're greatly clarifying the mental picture here for me. So it's almost like a bubble, right? I mean, there's like a roof and then there's a flat space, but it's all webbing. And
Yeah.
and where do the spiders live? I mean, is it
So
below?
in the solid part down there, you're going to see these holes everywhere, and these are retreats, and they're going to go there if, for example, if a bird comes and tries to eat them. Well, they go in these tunnels. So then they would just escape that way. So then they're protected by the web. So they either hunt on top of the web or they hide inside the web. and they've made this three-dimensional structure that can be the size of a basketball or the size of a house.
Yeah. Yeah.
And it's it's those tunnels that are on the outside that get abandoned when the nest gets too big, and that's when the other things that's what the other guys move into, those
Yeah.
retreats.
Okay. Okay. That makes the bats or the vipers or whoever.
Hmm.
Wow, fantastic. So okay, so look, you mentioned a lizard. What's the biggest thing you've seen social spiders uh attack and eat?
The well, actually the biggest thing I saw them eat was a grasshopper. It was a really
Oh,
really big grasshopper.
yeah.
But they covered it. It was you couldn't the grasshopper was on there for just seconds and then you couldn't see it anymore. There were so many spiders on it. I mean, they're
Wow.
like wolves, when they hunt together. And it's really cool. It's another emergent behavior because uh, they do this. They start coordinating their movement. They don't just go like this. They coordinate their movement and they turn. And you can see all these spiders that all start all over the web start turning and doing this jerking motion all at the same time. And they do this so that they're all moving at the same time. And when they stop, the only vibrations that are left are the prey. So
Oh, wow.
that's how they find it. So there's this
Interesting.
kind of emergent behavior too. It's not limited to building a web. It's also catching the prey that fall on the web.
Yeah. By dancing in time, by
Yeah,
moving in rhythm.
yeah, yeah.
Wow, that's super cool. I mean, it seems like potentially emergent strategies could help you take down bigger and bigger prey, right? I mean, maybe this is something like what wolves do too, right? In that if the dime-sized spider is nowhere, I mean, I've seen some pretty big grasshoppers, right? So, or a small lizard or something. Um, in hunting, right? If the individual's instinct is to just get hold of the prey and just bite and hold on, right? And but then 10 do it, and then 20 do it, and then 30 do it, right? Um,
Mhm.
maybe that's also an example where that very, it's not deliberate cooperation. They just all have the same behavior, and when they do it together, you can take down a big meal.
Right. Exactly.
Yeah. Wow, that's awesome. Fantastic. Rob, thank you very much. I really appreciate you joining us here, and look forward to having you out again in the future. And to the viewers also, thank you, and look forward to having you back in the Go for Wood Lounge next time.
Thanks for having me.